Hello everyone and welcome back to our channel. In this video, we'll be learning how to interface a vibration sensor module with Arduino and simulate the entire project in Proteus. This project demonstrates how vibration can be detected and displayed in real time using the LCD screen, a concept that is widely used in industrial monitoring, home security systems, structural health systems, and multiple other projects. Let's begin by understanding the working principle of the vibration sensor module. This module is designed to detect vibration or shock using spring-based vibration switches or any other sensor element depending on the model. It typically operates on 5 ports and provide two outputs uh, that are digital and analog. So let's understand its pins. The VCC is used for the power supply, that is usually 5 volt. The ground terminal is used to provide the ground connections. The digital pin sends the high signal when the vibration is detected, and the analog pin provides the variable voltage level corresponding to vibration intensity. The sensitivity of the module can be adjusted using the onboard potentiometer, as we'll be doing in our simulation. So let's create the circuit and see how it works. Open your Proteus and create this type of circuit as I have created one. As you can see, this is the module and it has all 4 pins that I have mentioned before. This is the test pin. Let me show you. This is the test pin and a potentiometer is connected to it. So as a user, we'll be using this pin. Changing the resistance of this pin will change the vibrations values, and these will be displayed here on the LCD. This is the Arduino, which will act as the heart of this whole project. So the signal that we are sending through this pin are going to Arduino, that converts the change in the voltages into the vibrational values, and it will show us the digital and analog values to this LCD. So this is the brain of this project. So if you have understood the circuit, let's move to the Arduino code. Before moving towards the code, I must mention that you must have included or installed this liquid crystal library into your Arduino. Once it is installed, you can paste the code here. Let's understand the code. In the very beginning, we are including this liquid crystal library, and after that I am mentioning the liquid crystal pins, the LCD pins that are connected to the particular pins of the Arduino. After that, we have defined the digital and analog pin. This is the analog pin definition, and this is the LCD means digital pin. This is the setup function that provides us the introduction of this project. After that, you can see we have the while loop that is read by the microcontroller continuously. This is a very simple project, and as you can see, it reads the analog vibration sensor value that is provided by the user. Those values are then uh, provided to the LCD, and LCD then displays its status. As you can see, that if the vibration value is uh, greater than 100, fine, then the status will be shown that the LCD is high, LED is high, and the sensor has sensed some vibration. You can change this value here if you want to adjust it, but I think this is the best value I can provide you. And this is the whole code, and to connect this code to our simulation, we have to provide the hex file address to our microcontroller. So how can we do this? we have to compile the code, and it will automatically provide us multiple type of information along with the hex file address created in your system. So we just have to copy it without any quotation marks, as you can see here. Copy it, go to your simulation, double click your microcontroller and paste it here as I have done before, and click OK. Now let's play the circuit and see if it works. See, it is working. It is showing us the uh, introduction, and after that it will provide us the current status. The vibration is 0. This is the analog value. The vibration right now is 0 and the status is no. That means there is no vibration here, because at the moment we have the highest 100% resistance on our potentiometer, and you can see here the voltmeter, the DC voltmeter also shows us the same value. Our digital pin is not working at the moment because there is no vibration. So let's change the values here. The resistance is changing. It takes some time to read the actual values, and as you can see here, the voltmeter is at 5 volt. That is the maximum value. Our digital pin is on now, showing that yes, there is a vibration right now. And on our LCD, you can see the vibration is maximum and the status says yes. It means right now we are providing the vibration and our sensor is sensing it, and our LCD is showing that yes, we have the vibration right now, and that is maximum here. I hope this project will help you, and this video was easy for you to understand. If you have any question, you can ask in the comment section.